section 9.1, our objective today is I can use the distance and midpoint formulas. So I have 2 points here, the point 31 and the point 66, and I want to know the length of this segment. And so what we can do is we can form a right triangle, and we see that 1, 2, 3, this has a length of 3, and 1, 2, 3, 4, 5, this has a length of 5. And so by Pythagorean theorem, we know that 3 squared plus 5 squared has to equal c squared. So the square root of 34 equals c. So this distance is the square root of 34. Okay? But the way that we came up with this 3 is that if this is x2 and this is y2 and this is x1 and this is y1, this 3 came from subtracting the x's. So that 3 came from x2 minus x1. And this 5, this length, came from y2 minus y1. So notice that if I do 6 minus 3, that gives us this 3. And if I do 6 minus 1, that gives us this 5. And then we took the 3 that we got here and we squared it. And we took the 5 that we got here and we squared that. So therefore, if we take x2 minus x1 and square that, plus y2 minus y1 and square that, that should equal the hypotenuse squared, or the distance squared. And so then if I take the square root of both sides, I get c is equal to the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared, which is the distance formula. So we say that the distance between P1 and P2 is equal to the square root of the difference in the x's, quantity squared, plus the difference in the y's, quantity squared. So by using the formula, we don't have to graph each time and form the right triangle. We can go directly to finding the distance. So example, if I have P1 equals 6, 2, and P2 is 0, negative 2, if this is x1, y1, this is x2, y2, then I just plug those into the formula. The distance or length of the segment formed by point 1 and point 2 is the difference in the x's, so that's 0 minus 6 quantity squared, and the difference in the y's. So that gives us negative 6 squared plus negative 4 squared. But negative 6 squared is 36, and negative 4 squared is 16. And so when we add those together, we get 52. And then 52 can be simplified because 52 is 4 times 13 is 2 square root 13. So the distance between point 1 and point 2 is 2 square root 13. Right, and then we also often want to know what is the midpoint of a segment. So if we come back here, and if we're looking at this segment, and we want to find the midpoint of the segment, we want to find the point that's exactly in the middle of that segment. And so we can find that point by taking the average of the x's and the average of the y's. So in this case, the average of the x's would be 6 plus 3 divided by 2, the average of the y's would be 6 plus 1 divided by 2. So this is 9 halves, and this is 7 halves. So that says that if I go over 9 halves, which is 4 1/2, 1, 2, 3, 4 1/2, and up 7 halves, which is 3 1/2, then that point is going to be the midpoint of that segment. Okay? So the midpoint formula is a midpoint is an ordered pair, and the midpoint is given by the x value of the midpoint is taking the two x's, adding them together, divide by 2, and the two y's, divide those by 2, and so this represents the x value of the midpoint, and this represents the y value of the midpoint. And remember, a point is always an ordered pair. All right, so example. Find, well, let me write that a little bit better. Find the midpoint of the segment joining the point 4, 1 and the point 1, -5. Alright, so we just take the x's and add them together, 4 plus 1, and divide that by 2, and take the y's, add those together, simplify that. So 4 plus 1 is 5 halves, and 1 plus -5 is -4 halves. So that simplifies to 5 halves and -2. So if I plotted these 2 points and connected them and then plotted this point would be exactly in the middle of the other 2 points. Okay? So let's do one more example. Find the distance and midpoint. Oops. Of the 2 points. Okay, so the first one is -3, -1, and -7, 5. Okay, so first of all, let's find the distance. So distance is equal to the square root of the difference in the x's, so -3 minus -7 squared, plus the difference in the y's. Then this is -3 plus 7 quantity squared plus -6 squared. So that gives us 4 squared plus -6 squared. So that's 16 plus 36. So again, we get square root of 52, which we know simplifies to 2 square root 13. So that is the distance between the 2 points. Now let's find the midpoint. Okay, so I'll just do it right here. So the midpoint is the average of the x's, so -3 plus -7 over 2, and the average of the y's. Okay, so -10 over 2 and 4 over 2. So -5 and 2 would be the midpoint. All right, so again, just to show you what that looks like, what you're actually doing is, let's go ahead and plot the points. So -3, -1, is right there. Negative 7, 5 is right here. Okay, so we found that the length of that segment is 2 square root 13, and we found that the midpoint of the segment is at negative 5, 2. So if I go over 1, 2, 3, 4, 5 and up 1, 2, then this is the midpoint of the segment.